2.1 Trig functions of acute angles. We've been dealing with trig functions, but all of the trig functions that we've talked about have been in relation to the unit circle or an angle on the unit circle. Well, today we're going to talk about finding trig functions in any right triangle. So if we have a right triangle, you know the parts of a right triangle, we have the right angle, across from the right angle is the hypotenuse, the other two sides are the legs. And so if we have one angle that's our right angle, of course the other two have to be acute angles. Well, we can find the trig functions, sine, cosine, and tangent, and their reciprocal functions in relation to one of those angles. So we have to specify which angle we're talking about. And in this case, we're talking about, this is called theta. So this is the angle in this triangle that is marked as theta. So just picture yourself standing on this angle. Well, if I look across to the other side, the side that's opposite that angle, that's called the opposite side. Side. The side that's touching that angle is called the adjacent side. And then, of course, the side that is across from the right angle is the hypotenuse. So we have these different parts of a triangle. Whatever angle that we are picturing ourselves as standing on, the other parts are going to be in relation to that. So say, for example, if this was my angle, then this side would be opposite that angle, and this side would be adjacent to that angle because it's touching it. The hypotenuse is always going to be the one that's across from the right angle. So now that we know what our different parts are called, we can use these ratios for our trig functions. The sine of theta is equal to the opposite side, the length of the opposite side, over the length of the hypotenuse. Cosine of theta is equal to the adjacent side over the hypotenuse. Tangent of theta is the opposite side over the adjacent side. Now there's a couple of different tricks to remembering these trig functions. SOHCAHTOA is a way that people remember the relations between the trig functions. So, S-O-H, CA, C-A-H, TOA, T-O-A. So that's sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. Another way to remember these trig functions is some old hippie caught another hippie tripping on acid. So whatever way you want to remember it, you do need to remember these trig functions. So now we're going to apply the trig functions. We're going to find the exact values of the trig functions for angles A and B. So if we are going to find the trig functions for angle A, we're going to pretend that we're standing on this angle. So we need to find sine of A, cosine of A, tangent of A, and then the reciprocal functions would be cosecant, secant, and cotangent. All right, so sine, we said, is opposite over hypotenuse. So opposite is 7. The hypotenuse is 25. So we know this is always going to be the hypotenuse. But in this case, since this is my angle that we're standing on, opposite would be the one that's across from it. And then this is touching angle A, so that would be the adjacent side of angle A. So sine, opposite over hypotenuse, so it's 7 over 25. Cosine is adjacent over hypotenuse, so that would be 24 over 25. Tangent of A is opposite over adjacent, so that would be 7 over 24. And once we get those three, for the reciprocal functions, all we have to do is take the reciprocal. So the reciprocal of cosecant is sine, so that would be 25 over 7. The reciprocal of secant is cosine, so that's 25 over 24. And then the reciprocal of cotangent is tangent, so we would get 24 over 7. All right, so that's all 6 of the trig functions for angle A. We're going to do the same thing with angle B. Okay, like I said earlier, the hypotenuse is going to stay the hypotenuse no matter which acute angle we're on. But in this case, since we're on angle B, opposite is going to be 24 and adjacent is going to be 7. So sine is opposite over hypotenuse, which would be 24 over 25. Cosine is adjacent over hypotenuse, so that's 7 over 25. Tangent is opposite over adjacent, so that's 24 over 7. And then we just do our reciprocals. All right, and those are the 6 trig functions for both angles. All right, if they want us to find the trig functions for, they're giving us the lengths of two sides, side A and side B. So just like if we were doing the Pythagorean theorem, we're going, it's got not A and B, A and C. We're going to assume that side C is our hypotenuse. So if we have a triangle, a right triangle, this would be, the length of that would be 7. And then it doesn't matter which one is A, we're just going to say that this is 6. So to find the length of this side, we would have to use the Pythagorean theorem. So we're looking for, I'm going to say we're looking for B, side B. So that would be A squared plus B squared equals C squared. And that gives us 36 and 49. I'm going to subtract 36 from both sides. So that gives me B squared equals 13. And then I take the square root. I don't need to put plus or minus in front because this is a length and we can't have a negative length. So we get that B is the square root of 13. Okay, so let me erase this. Now, this anytime we're dealing with triangles, the angle that's opposite the side has the same letter, it's just capital. So this is angle B, and this would be angle A. So then our right angle would be angle C. Okay, so we need to find the 6 trig functions for both of these. So if we start out on angle A, sine is opposite over hypotenuse. So that would be 6 over 7. Cosine of A would be adjacent over hypotenuse. So that's 13 over 7. Tangent of A is opposite over adjacent, which is 6 over 13. And then we do our reciprocals. 7 over 6, 7 over 13. I'm writing 13, it should be square root of 13. Okay, so that's square root of 13, square root of 13, square root of 13. And then for cotangent, that would be the square root of 13 over 6. Now, whenever we have a radical in the denominator, we have to rationalize the denominator. So we can't leave this one the way that it is. We need to multiply both the numerator and the denominator times the square root of 13, and that would give us 6 square root of 13 over 13. Right here, this would be 7 square root of 13 over 13, and I think that's it. It's okay as long if they're in the numerator. All right, let me change colors here. All right, so now we're going to do all the trig functions with respect to angle B. So now if we were standing on angle B, our opposite would be square root of 13, our adjacent is 6, and the hypotenuse is 7. So sine is opposite over hypotenuse, so that's square root of 13 over 7. Cosine is adjacent over hypotenuse, so that's 6 over 7. Tangent is opposite over adjacent, so that's square root of 13 over 6. And then we do our reciprocals. So we would get 7 over square root of 13, which we have to rationalize, and that would give us 7 square root of 13 over 13. Secant would be 7 over 6, and then cotangent would be 6 over square root of 13, which would rationalize to 6 square root of 13 over 13. All right, so now we're going to talk about cofunctions. Cofunctions are two trigonometric functions whose acute angles sum to 90 degrees and whose values are equal. For example, sine of 30 degrees is equal to the cosine of 60 degrees because their angles sum or add up to be 90 degrees and they both have the same value. The sine of 30 degrees is 1/2 and the cosine of 60 degrees is also 1/2. If you'll think back to the unit circle that we did, remember sine of 30 degrees, that would mean the y value at 30 degrees. And so the y value at 30 degrees is 1/2. Cosine of 60 degrees, that would be the x value. Cosine is the x value. The x value at 60 degrees would also be 1/2. So all of these are cofunctions of one another, or how we can find the cofunctions. Sine of A is equal to the cosine of 90 degrees minus A. And then the opposite holds true. Cosine of A is the sine of 90 degrees minus A. Secant and cosecant are cofunctions to one another. So either one, if you take 90 degrees and subtract the angle, it would be the cofunction. And tangent and cotangent are also cofunctions of one another. So example 2 says to write each function in terms of its cofunction. So for the cosine of 52 degrees, sine is its cofunction. So we would write this as sine of 90 minus 52, which would give us the sine of 38 degrees. All right, tangent is cofunctions with cotangent. So we would write this as cotangent of 90 minus 71 degrees. And 90 minus 71 is 19. So that would be cotangent of 19 degrees. And then secant's cofunction is cosecant. So we would write this as cosecant of 90 minus 24, which would give us 66. So cosecant of 66 degrees. And that's how we write functions in terms of its cofunction. Find one solution for each equation and assume all angles involved are acute angles. Well, knowing that cosine and sine are cofunctions of each other, we know that these two angles have to add up to be 90 degrees. So the way that we would solve this is we just add these together. Theta, let me write that a little better. Theta plus 4 plus 3 theta plus 2 equals 90 degrees. All right, so we're going to add these like terms together. This is like a 1 theta plus 3 theta. That would be 4 theta. And then 4 plus 2 is 6 equals 90. All right, we want to solve for the angle, so I'm going to subtract 6. And I get 4 theta equals 84. Divide by 4. And we get that theta equals 21. All right, so that's theta. Okay, for the next one, tangent and cotangent, same thing. We know that they're cofunctions of one another, so all we do is we take their angles in here and add them together and set them equal to 90 degrees. Plus theta plus 18 equals 90. Okay, so if we combine like terms, 2 theta plus 1 theta is 3 theta. Negative 18 and positive 18 cancel out. This equals 90. Divide by 3. And theta equals 30 degrees. Now we have some triangles that are considered to be special angles or special triangles. We have a right triangle that's a 30, 60, 90 triangle right here. Try to move this down a little bit. Okay, so if we have a 30, 60, 90 triangle, we have these ratios of the side that's across from the 30 degree angle is 1, the side that's across from the hypotenuse is 2, and the side across from the 60 degree angle is the square root of 3. Then for an isosceles right triangle that's 45, 45, 90, the sides that are across from the 45 degree angles are 1, and the side that's across from the hypotenuse is the square root of 2. So in any of these special triangles, we have the same ratios that we would in a unit circle. So if we were on the 30 degree angle, the sine of 30 degrees would be opposite over hypotenuse, which would be 1/2. Let's see, sine of 30 degrees would be 1/2. Cosine of 30 degrees, so cosine is adjacent over hypotenuse, which is the square root of 3 over 2. Tangent of 30 degrees is opposite over adjacent, which would be 1 over the square root of 3, which we would rationalize to be the square root of 3 over 3. All right, then for our 60 degree angles, sine of 60 degrees, so if we're right here, opposite over hypotenuse, that's the square root of 3 over 2. Cosine of 60 degrees, adjacent over hypotenuse, that's 1/2. And then tangent of 60 degrees, opposite over adjacent, so that would be the square root of 3. Well, these 1/2s and square root of 3s, remember we have all those values on the unit circle. So that's how it's related to the unit circle. If we were on the unit circle at 30 degrees, we know that the y value would be 1/2, the x value would be the square root of 3 over 2. And then on 60 degrees, the y value would be square root of 3, and the x value would be 1/2. Now for the 45, 45, 90 triangle, we can do the same thing. Of course, we only have to do it once because either way, we're on an angle that's 45 degrees, and the opposite of this angle is 1. The adjacent is 1. The opposite of this angle is 1. The adjacent is 1. So if we do sine, cosine, and tangent of 45 degrees, the sine of 45 degrees opposite over hypotenuse, that would be 1 over the square root of 2, which we would need to rationalize, and we would get the square root of 2 over 2. Cosine of 45 degrees, that would be adjacent over hypotenuse, which would be the same thing, square root of 2 over 2. And then the tangent of 45 degrees, opposite over adjacent, would just be 1. And then, of course, to get the reciprocal functions, we would just take the reciprocal of all of those. Now, there's an easy way to determine these, and I have another video that's called the hand trick. So watch that video, and that'll show you an easy way to get these trig functions.